Okay, so part 2 of these notes is going to be solving rational inequalities. So we've got equations, actually inequalities with x's on top and bottom. We're looking for solutions to x. And I think the big thing is that you need to get everything to one side, okay? And get a common denominator of on one side of the equation just to have one big solid fraction. You can't have all sorts of things. It just makes it too complex. The most important thing is to say, get all the terms on one side, get 0 on the other side, and then let's solve it. Okay, so in this first question, we're going to subtract that fraction that's on the right side, and you get x over 2 minus 5 over x plus 1, then minus x minus 4 over 3, and that's going to be greater than 0. So step 1, get all the variables on one side and get 0 on the right side, on one side. I think, pardon me as I yawn, I think the next thing is we need just a single fraction, and then we factor it, okay? And I think because we've got 3 fractions here, our goal is not really to get rid of the denominators. I think the big thing, it makes it too complex. If you've got an inequality, to get rid of the fractions, I think the best way to do it is to get it as a single fraction on one side, factor it, and then we'll look at some critical values to see where are the solutions. There's going to be a lot of solutions. It's not just a single answer. So we want to find those regions, and I think this is the best way to do it. So get a common denominator, and we're going to look for those critical values, okay? And that's what we're talking about here. So the common denominator is going to be a 6 and then an x plus 1. So if I multiply to get that to be true, I've got to multiply this by 3 and then x plus 1 on the first one, okay? Okay, and so our first numerator is going to be 3x and then x plus 1. Okay, yes, we'll distribute in just a second. Our denominator is going to be, okay, 6. Probably should erase this. It's going to be 6 and then x plus 1. Our second fraction, we will need to multiply by 6. And then it's subtracting, so we're going to distribute that to all the terms on that second one. So it'd be minus 30. Okay, there's only one, so it's really pretty straightforward. So x plus 1. And our last one, we've got to multiply through by a 2 and then an x plus 1. We need a 2 and then an x plus 1. We already have an x minus 4. This is going to get complex. Oh, wow, here we go. If you FOIL out those 2 parentheses, you get x squared minus 3x and then minus 4. Then we have to distribute not just a 2, but a negative sign here, so a negative 2. So I'm going to change this to be a plus sign, and I'm going to take negative 2x squared plus 3x, and then plus 8 over 6, and then x plus 1. I think the big thing is this is going to be 3x squared plus 3x. How you add and subtract fractions is you get a common denominator, and then you've got to add and subtract the numerators to get yourself multiple terms. So we're going to bring these all up here. Combining like terms, we're going to get x squared, 3x, and 6x is 9x. Actually, I lied. Let's see what's going on here. 6x. Okay, we've got it. So you've got x squared, and then you have plus 9x, and then you combine the numbers, the constants together. Negative 30 plus 8 is going to be negative 22. And then over, it looks like 6 and x plus 1. Now and we want that to be greater than 0. You're like, how in the world are we going to do that? Okay, and so I think the first thing is we want to factor this numerator. And so it does factor into x plus 11. Hi, kitty. X plus 11 and x minus 2. And then 6 and then x plus 1. And we want that to be greater than 0. And I think the big thing is you set each of the factors equal to 0, the factors with a letter, to get the critical values. Your critical values would be, from the first factor would be negative 11. You would like it to be 2 from the second factor, and then negative 1. Okay, and so because it's greater than 0, each one of these will be open circles. And what we want to do is to figure out where will be the solutions. The solutions will be between those points or on the extremities. And so you've got to do a test point. There's a couple ways to do this. My favorite way is just say, pick a number that's in each of these regions, and like you dip your toe in the top and be like, okay, try -12 and see if it works in the problem. Try -2, okay? Try 0, okay? And then between bigger than 2 would be like 3. So try each of those and see. Normally it alternates between these values, okay? My cat is very sad. Okay, baby. Okay, so we try this by saying, okay, where do you try it? And you can either put it in the factored form of the inequality, or you can put it in the original problem. I would get out your calculator and I'd be like, okay, I think I'm going to do it in the top equation. And make sure you put your x in a parentheses. And so if I do -12 squared, this is how I'd put it in my calculator. I'd put -12 and I'd square it. 144 plus 9 times -12, and then I do -22. I'd use the fraction key, and I would do 6, and then I would do -12 plus 1. Okay, and I would say, okay, is that going to be greater than 0? Okay, and so you can put that in your calculator, and just let your calculator do the work. As long as you put your values in a parenthesis and you type them in correctly, your answer should work. Okay, and I'm just going to put this in here, and I'm going to say, okay, let's square it, and then let's put 9 times -12. Hi, honey. And then -12. And then on the denominator, I'm going to do 6 parentheses, -12 plus 1. And then, okay, I get -4/11. That's not greater than 1. So I'm going to say, no, that's bad. Okay, those are not solutions to this problem. That's not even true. It's not greater than 0. Now what I will do is I'll pick a number in the next bracket between -11 and 1, because the answers will be between those critical values. And so if I go here and I say, okay, well, let's make this instead of -12, let's plug into my problem. You can arrow up on your calculator and say, okay, let's plug in -2 in this case. And if I put -2 here and -2 here and -2 here, okay, and you figure out what that is. And if I just go up and arrow up, and I'm going to basically just delete the 1 on each of those problems, delete, guess what? This is going to work because it generally alternates between yes and no. Okay, so delete, and guess what I get? 13/3. Is 13/3 greater than 0? Yes. Okay, so that means that the values between here and here will work. And so those solutions will be from -11 until -1. Okay, not including the endpoints. Okay, because we want it to be greater than 0. And let's check and see. If I plug in 0 to this problem, I'm going to change each of these values to 0. And guess what? That does not work. Okay, surprising. Okay, and then if I plug in the value in the last problem, like plug in 3 here, okay, I'm like, okay, let's plug in 3 for x into this original problem. 3 here, and 3 here. Does that answer make it greater than 0? And the answer is it will. Okay, and so it almost always is alternating in the truth value. And so this last value is going to go from 2 to infinity. So the solution set that makes this original problem true to make it greater than the other value on that side is going to be any value between -11 and -1, and then also from 2 to infinity. So it's pretty cute. How you do it is you get everything to one side, you make a single fraction, you factor the top and the bottom, you set those, find those, represent those critical values on a number line. If it's greater than or less than, make them open circles. And then do test points in each of those regions between the critical values. And then those answers will be as shown. Okay, so, in class, I would have us do the next question. So let's try this. Okay, we want to get everything to one side and make a single fraction. So let's subtract it. So x minus 2 over x plus 4. And then minus x plus 1. And then x plus 10 is greater than 0. I like 0 on the right-hand side, just to be honest with you. And then to get a common denominator, we're going to multiply the first one by x plus 10 over x plus 10. And you get x squared plus 8x minus 20. And then there's the denominator is x plus 10 and x plus 4. Here, let me help you. Okay. And then there's a subtraction sign. We're going to multiply the second fraction by x plus 4 over x plus 4. And then we have to distribute a negative 1 to it. So we're going to do that in a second. Okay, so you get x squared, let's see, plus 5x plus 4 over x plus 10 and x plus 4. Okay, I have to distribute this negative sign to each term in the numerator, combine like terms, and see what I get. Okay, so here we go. It looks like the x squareds will go away, and then 8 minus 5 is 3x. So we're going to get 3x, and then negative 20 minus 4 is minus 24 over x plus 10, and also x plus 4. The numerator could factor with a GCF of a 3, or you can just kind of leave it like that. There aren't multiple factors that have letters, and so that has to be greater than 0. So the critical values would be the factors that each of the factors equal to 0 on the top and the bottom. If you set the numerator equal to 0, you get 8. Okay, so 8 is going to be a critical value. Looks like on the denominator you get negative 10, and you also get negative 4. Okay, they're open circles because you have an inequality that's greater than or less than. And we've got to try values in each of those regions. And so I would say pick a value. I picked a negative 11. I'm going to pick negative 5. I'm going to pick 0, and I'm going to pick 9 and say, where are those answers? And it almost always alternates in yes and no. And so where do you plug them in? You can plug them into your factored form or your distributed form. I guess I'm going to go with this one right here. Okay, and again, I'll use my calculator and use the fraction key. And so I'm going to do alpha y equals, and I'm going to put in a parenthesis, negative 11 times 3, and then subtract 24. I'm going to put that over parentheses, negative 11 plus 10, parenthesis, another parenthesis, negative 11 plus 4. Okay, and I get negative 57 sevenths. That is not going to be greater than 0, so that is not true. Now, if I arrow up and I change all those x values in that problem to be not negative 11, but to be negative 5. Okay, now I'm going to use the delete key and the type over. So negative 11 is now going to become negative 5. And negative 11 becomes negative 5. And my answer is going to be 39/5. Hey, that is greater than 0. Okay, so that means that this second region is actually true. Now, if I plug in 0, okay, so I'm going to arrow up and grab this function, and where I see negative 5, I'm going to just put a 0. All right, and delete, and 0. And then up here, I'm going to delete and make that negative 5 into 0. Okay, I get negative 3/5. Well, that's not true. Okay, so we're using those values in those regions to say, dip your toe in the tub and see if they're true or not. I bet you if I try 9, it will work. Okay, and if I try 9 in place of 0, I am going to get, all right, I get 3 over 247. That is greater than 0. So that is another solution. So the values that would make this true will be from negative 10 up to negative 4, union with from 8 to infinity. So get everything to one side, find a common fraction, and then go ahead and do test points within each of those regions, okay? And then see where the answers would be. All right, thank you. Have a good day.